In this video, we will look at creating a dynamic two-dimensional array. First of all, let's look at a little bit of a review. In this program, there are a couple of regular arrays declared. We just have an unsigned integer array, values 20 all set to 0. And here's a 2D array, numbers that's 4 by 10 all set to 0. And I'm using a couple of functions that we will use to initialize them and to print them out. So we've got an initialize 1D and a print array 1D function. And here I'm calling an initialize 2D array and a print 2D array. So let's scroll down and look at those functions briefly. So they're way down here. In the case of initialize 1D, it's very easy to pass an array in, and it doesn't matter how big the array is. The parameter, the formal parameter, is just the name of the dummy argument here, the formal argument, and you can use an empty set of brackets. So that means that this function will accept any size array, and will also pass in how big that array is. In the case of the two-dimensional array, though, we have a problem. We have to specify the number of columns. We cannot leave that empty. We have to put a value there. And in addition to that, any array that we pass into the function, it has to have exactly 10 columns. So that might be an issue, because what if you wanted to have an array that had 20 columns? Then you couldn't call this function to print it. You'd have to write another function that had 20 here for the number of columns. The dynamic array that we will look at in this lesson will show you a way that you can get around that. You can have one function that will print out an array with any number of rows and any number of columns. Now let's scroll back up to the top, and when we are calling the functions, you see that we are calling initialize 2D and print 2D. Then we pass in the array numbers, and that array numbers has to have exactly 10 columns. Let me show you that there's an error if we try to call the function either initialize 2D or print array 2D with a different number of columns. So temporarily, I'm going to change that 10 to an 8, and then you'll immediately see that we have red underscores. And the error that we're getting, if I can keep that up, it's saying that the argument with 8 columns is incompatible with the 10 column dimension of the function. All right, so that's the problem that we've run into, and this program will show you an alternative way that you can use to solve that problem. So let's put this back at 10. And let's actually go ahead and compile and run the program. You can also see we have the prototypes for all those functions up there. So let's compile and run the program, and we'll see what the output looks like. Then the program will stop right there. Then we'll move into the dynamic arrays after we illustrate what these initialize and print functions do. So I'm just going to build this program, and then I'm going to run it. So the window has appeared, and shortly we'll see the output. Here we go. In this output, you can see that I printed out the elements of the array for values. So it's just a one-dimensional array with 20 values, and you can see those printed out here. The far right-hand column shows the actual address where these elements of the array are stored in memory. If we scroll down, then I've also called the initialize and print function for the 2D array, which is 4 by 10. So here you can see the output from that array. Okay, so there's the first row, index 0, the second one, index 1, the third one, index 2, the fourth one, 3. So here are the output values of our 4 by 10 array. And then we have stopped temporarily at this point. So I'll stop the program, And let me scroll back down to the functions one more time because I do want to point out the output of the address. And the print array 1D function, the output is just we pass in the one-dimensional array, and we have the for loop that will print out this cout statement, or will execute the cout statement. So the output is just a nice string constant with array with a left bracket, and we'll print out the k index, close the right bracket, then actually print the actual number here. And then I wanted to point this out. If I want to print out the address of anything, a regular variable or an element of an array, then I use the ampersand, which is the address operator, and I'm going to convert that to a type int. If I do not do this, then the address comes out as a hexadecimal value, which is a little harder to read than just a decimal value. Okay, so that's where that table is generated. We have the variable and the contents and the address. Now, let's scroll back up and write some code that will generate a dynamic array. Okay, so we'll move down to here. If we want to make a dynamic array, then of course we need some pointers to do that. So I want to make a pointer to an unsigned integer, and I want to make 4 one-dimensional arrays. So I'm going to call these star row 1, star row 2, star row 3, and then finally star row 4. And let's change that, change my typing to a comma. And again, Visual Studio prefers that syntax, but I do not. So I like to have my asterisk immediately to the left of my variable. All right, so now we have the pointers for 4 one-dimensional arrays of unsigned integers. Okay, they don't have a value yet, so we do need to initialize them. And to initialize them, we need to use the new designator. And I want to also type in how big I want these arrays to be. So let's put that down here. All right, so we'll create the 4 one-dimensional dynamic arrays, but the user gets to choose how many columns. All right. So after we input the number of columns, then we can do the new. All right, so we can initialize them now. So row 1 is equal to a new unsigned integer. And the number of columns that we input will be how large the array is. All right. Now this new operation is just requesting some space from the operating system. So the operating system finds the space, it returns the address in row 1. This created a one-dimensional array called row 1. Now let's do the other 3. So I'll just copy and paste, do a little bit of editing. So now I just need to make that row 2, row 3, and row 4. So this generated 4 one-dimensional arrays. These are 4 one-dimensional dynamic arrays because we're using new, and we've input the size that we want. So all of this takes place when the program is running, not during the time it's compiled. We want to initialize the 4 one-dimensional arrays, so we have a function that will do that. We already have this initialize the 1D function. So we'll do initialize 1D, and the argument will just be row 1, and how big is it? Whatever the user wanted to type in. So we can pass row 1 to the function, and we can use it as we would an ordinary one-dimensional array with the square brackets. I want to initialize the remaining 3 arrays, so I'll just cut and paste or copy and paste and change this to row 2, this to row 3, and this to row 4, so we can print out the values. We can initialize them, and then we can print out the contents of the arrays. what I have done here is I've already got some code to do that, and I had just commented that out because I didn't have these row 1 through row 4 generated yet, and it would not compile otherwise. So now that we have allocated the space and that we have initialized them, then we can print them out, and I'll just uncomment these lines of code. So this will print out the contents of row 1. The next one will print out the contents of row 2. Then we'll do row 3. And finally, we'll do row 4. So we're calling the print1d function, and it will print out the values that were loaded into these one-dimensional arrays. Now, remember, we created these arrays dynamically with new, but we can treat them just like an ordinary static array and pass them to the function. So we can initialize 1D, we can use the square brackets here, so that is perfectly fine. Now let's compile and run the program, and let's see what the values were for these 4 arrays. So the program has compiled and it is running. So here we see the previous output from just the one-dimensional array of values. Here's the two-dimensional array, the 4x10 array. Then we are down to the system pause. Let's hit enter or space key. And how many columns do we want? Dynamically for each one of these, we want 5. And here is the output. So this says row 1 is stored in memory at this address. That's the actual location where this pointer is stored. And it contains the value 7176992. So row 1 is a pointer, and it points to the address of the first element of this array 0 in the function, and we're passing in row 1, so that's a row 1 sub 0. Row 2 is also a dynamic array. It has a place where the pointer is stored. That's its address. The pointer contains this address, and that points to the first location of the row 2 array. One thing you should notice is that these are not stored in consecutive locations. So this address points to the beginning of this array with 5 elements. These numbers are consecutive, but when I generate the second dynamic one-dimensional array, it is not at the consecutive to the last element here. So these 4 dynamic arrays are stored in 4 different blocks of memory. Each element of each array is consecutive, as you can see here, but these 4 different arrays are stored in different blocks of memory. So that will be important in what we'll be looking at shortly. So let's stop the program at this point. Now, what I'd like to do at this point is to look at a graphical representation of what this program has done up to this point. So I'm going to switch to a PowerPoint presentation or a couple of charts to show graphically what we have just done with the program. Now let's look at a PowerPoint chart that will illustrate what we just did. This PowerPoint chart, on the left-hand side, I've copied and pasted the code from the program. On the right side, you will see 4 tables, and they represent each of the 4 one-dimensional arrays that were produced. Up at the top, I'm assuming row 1 is going to point to address 2000, which is the first element of the row 1 5-element array. The table shows the pointer notation at the top row. The square bracket notation is the second row. That's what the variable is pointing to. The contents will be the numbers produced by the random number generator, and the bottom one shows the addresses where each of these items is stored. So the first element of the array is 2000, the second one 2004, the third one 2008. So unsigned integers take 4 bytes, so that's why these go by 4. The remaining tables, row 2, row 3, row 4, also show graphically what is produced when we do the new unsigned integer for row 2, row 3, and row 4. I'm just picking some numbers for the addresses, 1104 for row 2, 1184 for row 3, and 1264 for row 4. So when we execute the new unsigned integer and we have the 5 columns that I entered, then we call the initialize function. Then this is what we get in memory. So these 4 groups of 5 element arrays, we have 4 one-dimensional arrays with 5 elements, those are stored in memory at some location. So we will use these 4 one-dimensional arrays coming up when we get back to the program. Now let's add to the program. In this area, it says make an array of pointers to an unsigned integer. Notice what this says. It says make an array of pointers. So we're going to have a variable that's going to be an array, but it's going to have pointers as the contents. Alrighty, so I want to set the rows equal to 4 because we made 4 rows previously up above. And I want to declare a new variable, which is an unsigned integer, but it's a pointer to an unsigned integer, and I'll call it table. And I am going to make it this many rows. So I could put 4 here, or I could just put rows there. Alrighty, now this line of code is, well, why does it not like that? Okay, well, let's just put 4 in here. Now, what this is saying is that this variable table, which has 4 elements, will contain pointers to unsigned integers. So it will not contain just regular unsigned integers, it will contain pointers. Now, let's initialize this table with the pointers to the 4 one-dimensional arrays that we did up above. And we'll just do this. Type each one in. So table element number 0 is equal to row 1. So row 1 is what was produced when we did a new operation up above, right here. So we had an address returned, and that was saved in row 1. So row 1, sure enough, that's a pointer to an unsigned integer. So we're going to save that as an element of this table, which is a table containing pointers to unsigned integers. Okay, so let's copy and paste. We'll do the other 3. So we'll set these indices, table 1, table 2, and table 3. And we will make table 1, it'll contain the address of row 2. Table sub 2 contains the address of row 3. Table sub 3 contains the address of row 4. So we have now just loaded in these 4 pointers into the table. Down below we have case number 1, we have a cout statement which says we want to print out the dynamic array for table case 1. Well, the dynamic array part of this is not the table itself, but it is what the elements of the table point to. So row 1, 2, 3, and 4, those are all dynamic arrays. Now we have a function already that will print out a one-dimensional array. So it's down here. So we have print array 1D, so we can use that. And we have to be careful about what we send into it. Right, so now let's back up and let's call this function. And we need to print out all of the elements of the table. So let's just do for int k is equal to 0, k less than 4, k plus plus. I've got a lowercase k. Then we just need to call print array. So print array 1D, and the thing that we need to send to it is going to be each row of the table. So this index, or this argument is going to be table sub k. So the print function is just expecting one table of unsigned integers. So this will be the pointer to that. And how many elements does it have? Well, we already know that it contains a number of columns that we entered up above when we did the new operations for row 1 through row 4, and it was 5. Now, let's put a system pause here so we don't go any further, and then we'll compile and run the program. We'll put the correct print over here. Okay, now let's compile it and run, and let's see what we get. Here's the output. We had the previous output from the program we did last time showing up here, and now we've reached the part of the program where we type in how many elements we want in each of these one-dimensional arrays. We chose 5, and then we did print out the contents of those 5 rows. Let me ask you to remember these numbers here. This is row 1. Okay, so array 0, 1, 2, 3, 4. So those are 5 elements for the table row 1. 16, 35, 90, 42, and 38. So keep those in mind as we go down. As we get to the bottom here, I am ready to hit the enter key, and we will do this part of the code that we just typed in where we put some values into a table. So I'll hit the enter key, and we now have executed this part of the code, and we have gone through our little for loop to print out the values. If you look back at what we have, then this says print dynamic array table case 1. So that came from right here. And the output of that is the same as we got up above. So table sub 0 is passed in, and it's a one-dimensional array, or it's a pointer to a one-dimensional array. And here are those same numbers, 16, 35, 90, 42, and 88. So what we have done here when we passed in table sub k is exactly equivalent to what we did up above when we passed in row 1, row 2, row 3, and row 4. That shouldn't come as any surprise because we set the elements of the table to these pointers, row 1, 2, 3, and 4. Now what I want to do before we go on is I want to stop for a moment and bring back in another chart that illustrates what we just did. So I'm going to switch to a PowerPoint chart. This chart shows a picture of what we just did. On the far left, I have just copied and pasted the code. So we had the rows as 4, and we did the unsigned integer pointer to table. So now the table is there, and it contains these addresses. We loaded up the table with the addresses, the pointers, row 1 through row 4. Directly below that, you'll see a table that represents the table variable, and I'm showing you the variable, what the notation is, pointer notation, the variable with bracket notation, and then look at the contents column. So table sub 0 contains 2000, and that is the 2000 that we are just assuming is going to be assigned as the address of row 1. The contents of the second one, the second element, index 1, is 1104, and that's just the address of a row 2. And then so on down the list. So just using those numbers I made up, then you can see that the table indices 0, 1, 2, 3, and 4, those contain the addresses of row 1, row 2, row 3, row 4. The column on the far right, I'm just picking some addresses where the table could be stored in memory. So the actual table, I'm assuming, could be at addresses 2800 through 2812. But the actual contents of each of the locations is shown as 2000, 1104, 1184, and 1264. I've also added some arrows so you can see that the table contains pointers to the 4 one-dimensional arrays that we previously created. Now let's add to the program. In this area, it says make an array of pointers to an unsigned integer. Notice what this says. It says make an array of pointers. So we're going to have a variable that's going to be an array, but it's going to have pointers as the contents. All right, so I want to set the rows equal to 4 because we made 4 rows previously up above. And I want to declare a new variable, which is an unsigned integer, but it's a pointer to an unsigned integer, and I'll call it table. And I am going to make it this many rows. So I could put 4 here, or I could just put rows there. Alrighty, now this line of code is, well, why does it not like that? Okay, well, let's just put 4 in here. Now, what this is saying is that this variable table, which has 4 elements, will contain pointers to unsigned integers. So it will not contain just regular unsigned integers. It will contain pointers. Now, let's initialize this table with the pointers to the 4 one-dimensional arrays that we did up above. And we'll just do this. Type each one in. So table element number 0 is equal to row 1. So row 1 is what was produced when we did a new operation up above, right here. So we had an address returned, and that was saved in row 1. So row 1, sure enough, that's a pointer to an unsigned integer. So we're going to save that as an element of this table, which is a table containing pointers to unsigned integers. Okay, so let's copy and paste. We'll do the other 3. So we'll set these indices, table 1, table 2, and table 3. And we will make table 1, it'll contain the address of row 2. Table sub 2 contains the address of row 3. Table sub 3 contains the address of row 4. So we have now just loaded in these 4 pointers into the table. Down below we have case number 1, we have a cout statement which says we want to print out the dynamic array for table case 1. Well, the dynamic array part of this is not the table itself, but it is what the elements of the table point to. So row 1, 2, 3, and 4, those are all dynamic arrays. Now we have a function already that will print out a one-dimensional array. So it's down here. So we have print array 1D, so we can use that. And we have to be careful about what we send into it. Right, so now let's back up and let's call this function. And we need to print out all of the elements of the table. So let's just do for int k is equal to 0, k less than 4, k plus plus. We've got a lowercase k. Then we just need to call print array. So print array 1D. And the thing that we need to send to it is going to be each row of the table. So this index, this argument is going to be table sub k. So the print function is just expecting one table of unsigned integers. So this will be the pointer to that. And how many elements does it have? Well, we already know that it contains a number of columns that we entered up above when we did the new operations for row 1 through row 4, and it was 5. Now, let's put a system pause here so we don't go any further. And then we'll compile and run the program. We'll put the correct print over here. Okay. The other thing we need to do is when we call the function, I hard-coded in the number of rows and a number of columns. So I want to change the size of the array. So when we type in the number of columns that we want up here, that will be different than the 5 that I just used. So I want to generalize the program so that when I call print array 2D star, we actually send it a number of columns. C-O-L-U-M-N-S. All right, so now whatever size array I choose, then it will work okay. So we will build it and run it one more time. Here's the output window. This time, enter number of elements. I want to make a different sized array. So I'll pick 8. I think I'll pick 8, type in 8, enter. So now you can see that each one of the arrays, they're still called row 1, row 2, row 3, row 4, but they each have 8 elements, indices 0 through 7. Now we continue to go down through the program, and I'll type enter again. So this is the result when we call print dynamic array case 1. Then we're ready to hit enter, and we'll get the printout from case 2. So now you can see there, print dynamic array table case 2, and this time I'm printing out an element, an array that has 4 rows, and in each one we have 8 elements. So here's a two-dimensional array. The first index is the row, the second index would be the columns. But I'm using the same function. So I have used two different arrays, but I've used the same function to print them out. And the big deal here is that it did not complain about having a different number of columns this time. So in the old way, I had to stick with a 10-column element over here, or whatever I put there, that was the only sized array I could send in. But now, with this new technique, where I'm using a dynamic array, then I can call print array 2D star with any size array that I want to. So this is how we get around the restriction of having to have the number of columns hard-coded in advance and it cannot change. There. So that finally completes this program, and there was quite a bit involved. So if you didn't get everything, then I hope you will just go back and go over the parts again to see how all this works. So that brings us to the end of this example.